Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good evening to our classmate and also our maybe level lecturer, Dr. Nur Khairunisa. So we are group 4, which is the group with the title project, which is the syndrome. So my teammate include me, Shafiq, and also others, Amir Imran, Ahmad Aidit, Muhammad Nur Ibrahim, and also Clarissa. So we will begin our presentation. So next slide, please. Okay, so the first begin, I will to invite Noor Ibrahim to deliver his presentation. Please welcome.
Okay, Assalamualaikum. First, I will introduce what is drone taxi. Drone taxi, also known as flying taxis or vertical takeoff and landing vehicle, was made at 2010. Drone taxi are type of aircraft that are designed to transport passengers over short distance. It use electric or hybrid propulsion system and are able to take off and land vertically, making them well suited for urban environment where traditional aircraft would be impractical. There are several companies and organizations currently working on the development of drone taxi. The first is Uber. Uber announced its plan to develop a network of electrical vertical takeoff and landing aircraft. The next organization is Joby Aviation. Joby Aviation is developing a five passenger electric aircraft. Next slide, please. There are several challenges that need to be overcome in order for drone taxi to become a widespread transportation option. The first challenge is safety concern. The safety of passenger and other on the ground is one of the key issues with drone taxi. Next is regulation holders. And the last one is design and construction of drone taxi. Okay, next. For design part, I will pass it to Shafiq.
Okay, thank you, Ibam, for your presentation. So my part, which is the part design. So we are comparing with the current design and also new design. So everyone can see the left side is our current design that we serve, and now the right side is our new design. So basically, the new design that we made with Katia to make the design. So next, please. So component for our taxi drone, which is conclude six component, which is fuselage, intake, right and left wing, railing, flap, and also propeller. So basically, I will to intro. The flap is the compartment inside the intake. Okay, next slide, please. So this is our Katia component, which is the fuselage. Next. So this is intake. Okay, next. This is a right wing. So that is a left wing. Next. So this is a railing. So the compartment ini and can see the downward of fuselage. Okay, next. So this is a flap. So before that, I said the flap is the compartment inside the intake. So the function of flap is when the taxi drone want to turn the right. So the flap can open the one side so that air can flow the through, make the taxi drone wait to turn to the right. Okay, so basically this is a function of flap. Okay, next. Okay, so this is our propeller. Next. So after assemble the six of component of taxi drone, so that is our assembly design. Tada! Voila. Okay, next. So for the material specification, I will invite Ameh to give his explanation. Please welcome.
Thank you very much to Mr. Shafi for presentation just now, and I will continue my parts of material specification. So first things first, it's all about fuselage. So the fuselage is made from materials of aluminum 2T24 T351, which is on one of the derivation or aluminum alloy family known as 2T24 T351. It is made of from combination of aluminum, copper, and magnesium, high strength, good heat resistant, good fatigue resistant, and lightweight to provide longevity of fuselage, which is also corrosion resistance, but it can be improved by cladding with pure aluminium. So these characteristics are suitable for constructing fuselage. So the second part is the intake. So the material used for intake is aluminum 6061 T4. What does it mean about T4, by the way? So T4 is a solution heat treated and naturally aged to a substantially stable condition. And then it provides different mechanical properties with respect to temper, which is T symbol, and precipitation hardened technique aluminum alloy, which is contain magnesium and silicon. Possess good mechanical properties, good weldability, and lightweight, which is around 2.70 gram over centimeter cube. High corrosion resistant when exposed to air or water, generate an oxide layer that protect underlying metal from corrode and exposed to the element, which is why it is suitable for constructing an intake. So next, our wing. Our wing material used are aluminum 7075 T6. Main aluminum element is zinc and high strength, good toughness, good fatigue resistant, lightweight, which is around 2.70 gram per centimeter cube, and outstanding ductility, which is able to welding and provide a varied shape. High corrosion resistance compared to aluminum 2000 series, preferably used for critical parts for instances wing section. And then flap. So the material used for flap is aluminum 7010 T6. Similar to aluminum 7010 T6 just now, it just main alloying element is zinc. Possess high strength, high fatigue resistance, lightweight around 3.0 gram over centimeter cube, and hardness that provide resilience to impact. Flap operate at relatively medium temperature depending on the environment. Absence of copper in the chemical composition of this aluminum alloy increase lifespan of the component. And then lastly here we got propeller and railing, which is share both the material use, which is titanium alloy, a specific grade 5, 6 aluminum, 4 vanadium, containing 6% aluminum and 4% vanadium. Outstanding strength to weight ratio, which is 4.42 gram over centimeter cube. Incredible use strength characteristic that is suitable for critical moving parts, for instances, propeller and railing. Excellent hardness to withstand rolling over the weight during landing. So I will pass to ID for next discussion. So please welcome.
Thank you, Amir, for your impressive presentation. Okay, now I'll talk about the justification of why we made some changes of and development of this design and material. So the material that used to build this drone must have a low weight, high specific strength, resistant to heat, fatigue to load, cracking and corrosion, and the ability to fly with air support while resisting gravitational forces. So the first drone that were made of carbon and plastic in the past. However, plastic and carbon-based drones, we know that it's required frequent upkeep and rapid deterioration. So the research for better materials began as a result. Steel, titanium, aluminum, and composite are now the preferred building materials for drone taxi structures. Next, Amir. So, aluminum is utilized due to its low density, high strength, high corrosion resistance, good thermal and electric conductivity, and technological efficacy. However, aluminum is not utilized for aircraft skin surfaces because it loses to its high strength at high temperature. So steel can be 3 times stronger and heavier than aluminum because it is an alloy of iron and carbon. Due to its strength and hardness, it is typically used in landing gear and aircraft skin due to its high heat resistance. Due to their low weight and high corrosion resistance, high tensile strength, and high compression resistance, we prefer that composite material for this drone production. A base material and a resin that strengthen the material as the whole makeup composite material. The aircraft fuel efficacy, performance, and direct operating costs that are both enhanced by composite material. Fiberglass is that most widely used for composite material, consisting of resin matrix and glass fiber as a base material. However, one of the drawback that used for composite material is that they are expensive and necessitate immediate repair in event of damages. When using composite material, it is also critical to avoid fire because the resin used weakens and release toxic fumes. So next, Ameh. So when we made some changes and development through this design and material, of course, it made some impact on the society. So the main thing that impacted for these changes is that the traffic congestion. Traffic congestion is a major issue for people that all around the world, especially people in the urban areas like us. Additionally, this situation is getting even worse as the population grows, the world population grows. Commuters that have to wait in the traffic for hours and which cause significant delays every day. Like us, we use KTM, LRT that usually have delays. As a result, government and citizens are looking for practical ways to elevate the traffic congestion. So the drones have made many of the important tasks in agriculture and also aerospace and other industry easier to do. However, drones can be used in more than just agriculture and aerospace industry. In Dubai, for instance, they are trying to use trying out the drone taxis that can take passengers where they want to go. So these drone taxis have the potential to solve traffic issue and become a common mode of the transportation in the future. So other than that, it is impact on the environment and nation. So the first one is reduce delay. Drone taxis may able to offer available answers to the issue with traffic at the moment. Additionally, flying is unquestionably a lot quicker than driving. When all these factors are taken into account, it becomes clearer that drone taxis can speed up people's commute. And it also lowered the carbon emission. For your information, the vehicle pollution annually causes 4 million children asthma, nearly 4 million children every year. Additionally, it is common knowledge that vehicles that runs on fossil fuels emit greenhouse gases that made some climate change and global warming. As a result, vehicular pollution is a major issue. The manufacturer of drone taxi will power vehicles with electricity. So the drone taxis won't contribute to the climate change, and this taxi may contribute to mitigating the effects of climate change. And the last one is decrease cost. Although the technology used in drone taxis may appear costly, this may not be the case because the manufacturers of drone taxi anticipate that their prices will likely to comparable to those of conventional ride-sharing options like commuters, KTM, and others. Prices may also fall further as self-piloting technologies advance and drone taxis are manufactured in large quantities. Additionally, the passengers may be able to save even more money on their commutes by taking advantage of pooling service provided by drone taxis. As a result, passengers may eventually use drone taxi as common mode of transportation. So I'll pass to Claire for the conclusion. Thank you.
Thank you so much. So, I am Clarissa. I will continue to conclude our presentation for today. To conclude, drone technology must be improved continuously in order to remain sustainable. We create the drone taxi that can be sold on the market for commercial purpose. Furthermore, we selected the drone taxi because it has intriguing design components and the potential for commercial success. The usage of drone taxis in various applications will be successfully illustrated in this project. Last but not least, drones may make a significant contribution to environmental sustainability in this situation by helping with asset inspection, agriculture, animal tracking, and disaster management. That's all from us for our presentation today. Thank you for listening.
So that's all from us, our team member. So we present our project, which are taxi drone. So how you everyone can understand our presentation. So hope see you guys for next session or next time. Okay, bye. Thank you. Assalamualaikum. Bye.
Thank you. Assalamualaikum.